Hi there, in today's video we'll try to explain how a circuit breaker works. First, note that electric energy is transmitted through two wires to our homes. The first wire, which is the live wire, and the second one, which is the neutral. We usually use the grounding wire to protect us from electrocution due to any short circuit or any failure. The grounding wire will drain the electric current to the ground. Let's now explain how a differential circuit breaker works. Note that the intensity of the current in the live wire must be equal to that of the neutral wire. And if there is any leakage for any reason, the differential circuit breaker will measure this leakage and it will trip off or cut off the circuit. So in a differential circuit breaker, the current entering and the current leaving will be measured by the circuit breaker, and for any leakage, the circuit breaker will trip off the current. Let's now talk about fuses. We have different types of fuses. Most of them are used in appliances and in your car. Fuse will allow certain intensity of current to pass through it. Once there is an overload, the fuse will blow out, and in this case the machine will be protected. A wire is characterized by its length L, capital L, by its cross-sectional area, capital A, and its resistivity rho. What will happen if we increase the length of a wire, or if we increase or change the cross-sectional area, or even though the resistivity? As much as we increase the length of the wire, the resistance will increase too. If we try to increase the cross-sectional area, it's inversely proportional, and this will decrease the resistance, allowing more charges to flow through a wire. And finally, if we change the resistivity of a wire, the resistance will increase. Let's try to check an application. In this application, you will see we have a wire named D1, and the resistance of this wire is 100 ohms. The question is that what will happen to the resistance of a similar wire made up of the same material but with a length of 4 times longer and half its cross-sectional area. So we'll use the same formula, which is R equal to rho L over S. The resistivity is the same, so rho will remain the same. The length will multiply 4 times L1, and the first cross-sectional area will be divided by 2. Then we will get 8 multiplied by rho L1 over S1, and the highlighted part refers to R1. Substituting the value will provide 800 ohms. So as you can see, if we increase the length and decrease the cross-sectional area, the resistance of the new wire will be 8 times bigger. That's all. Thank you for today.